Hello guys and welcome back to my channel Interview with Bunny, and today we are on the 16th video of our graph playlist, and today we will be solving the problem on LeetCode, and that is the course schedule. So this problem is very important problem based on the Kahn's algorithm that we have learned in our last video. So it is highly recommended to you that if you are coming to this video for the first time, do check out my last 3 video on graphs, that is lecture 13, 14 and 15, because without going through these 3 lectures it is impossible to understand this problem. But if you have already gone through this video, then solving this problem will hardly take 3 to 4 minutes to code, because this problem is completely dependent on the algorithm, that is the Kahn's algorithm, and we will be using the exact ditto same code and we will be pasting it over here, and I will prove that with the help of the Kahn's algorithm, you can easily solve all these problems on the graph. So without wasting much time, let's first understand the problem and let's see how it is related to the Kahn's algorithm and how we can solve it. So let's first read out this question. So the problem statement states that we have some courses over here and the total number of courses is num courses. And we are given an array called as the prerequisite array, which is represented by A and B, which indicates that you must take course B first if you want to take course A. What does it mean? It means that for the pair 0, 1, to take the course 0, you have to take the course 1 first. That is the main basic thing that you have to understand. And if you understand this single line, solving this problem is damn easy. Because what you have to solve that you have to return true if you can finish all the courses. Otherwise, you have to return false. So let's go through this example and let's see what it actually means. So the problem states that we are given some number of courses. So for example, for the first test case, the number of courses is 2. So we have a variable called as number of courses and it is 2. And we are given a prerequisite array which is nothing but 1, 0. And here 0 and 1 are nothing but the name of the courses. So 1 is one of the course and 0 is another name of the course. And this prerequisite array tells that to take the course 0 means to take this course, you have to take the course 1 first. Means our course 0 is dependent on course 1. So our arrow will be something like this. Means this course 0 is dependent on course 1, because here as the problem statement says that course 1 is independent, means here the dependency value is 0, but the course 0 is having a dependency of 1 since it is dependent on course 1. So here the dependency is 1. So this is actually what the problem statement is telling. So our real objective is whether we can take all the courses or not. So if you think this as a problem of graph, what it actually means, we have to see whether it is possible to visit all the nodes of the graph or not. Means whether there exists a cycle or not. So if there exists a cycle in this graph, so obviously as we have discussed in our last video, it is not possible to iterate over each and every node and to create a linear topological sort. So our real objective is we have to see whether we are having a cycle in this graph or not, which we have already solved in our last video at the very last. And I promise you with the same code, we can also solve this problem. So here also it tells that you have 2 courses, that is 0 and 1, but the prerequisite array that is given is something like this, that is 1, 0 and 0, 1. Means if we just draw the graph out of this one, so we have 2 courses 0 and 1, and for the first dependency array means this one, our direction goes from 0 to 1. But for the next prerequisite means this one, our dependency is from 1 to 0. Means there exists a cycle over here, and if there exists a cycle over here, we have to return false for this case, and in this case we have to return true. This is the only ask for this question, and I hope you already know how to solve this. So without wasting much time, let's get started, because over here there is nothing new. We can simply use our existing code and we can simply solve this problem. So let's get started. So the first thing that I did is like I have opened the Kahn's algorithm over here, which we have learned in our last video. So this was the program for the Kahn's algorithm. So what we will do, we will simply copy this code from here. So this is our graph implementation. So this is the boilerplate code to create a graph, which we are using for all our videos. Now let's start with the implementation. So what we have to do, we have to simply create a graph object and we have to implement the Kahn's algorithm. So what we'll do, we'll first start with creating the graph object. So let's create an object over here called as graph. And based on this prerequisite array which is given, we have to just create the graph class. That is the only objective or the only few lines of code that you have to do. So what I will do, I will first iterate over this prerequisite array. And here we will create the graph object. So what we'll do, we will call our function that is add age. And here we will be passing the two nodes of the graph. For this problem, if you look carefully, the prerequisite array that is given is in reverse order. Means A is not dependent on B, rather B is dependent on A. So what we'll do, we will simply reverse the creation of the graph. Means here it will be not 0, 1, rather 1, 0. I hope this is clear to you why we are doing in this way. This is quite basic. Now what we have to do, based on the Kahn's algorithm, we have to create the in-degree array. So let's create an array called as in-degree. So we'll define an array over here and we will pass the total number of courses. And here we will increment our in-degree array. And that's it. This is the only bit of code that you have to do to solve this problem. Apart from creating this graph class, everything is there in the Kahn's algorithm that we did in our last video. So let me copy that. So here what we will copy the way we have done the Kahn's algorithm. So this is the main meat of our Kahn's algorithm. So let me copy and paste over here. So what we are doing, I hope you already know that here we have a queue and we are putting the courses on the queue whose in-degree is equal to 0, means the dependency is 0, and here we are simply iterating over the queue. But here the problem is very simple. Here we do not have to print out all the courses, rather we have to just detect whether there is a cycle or not. So we do not need an additional data structure called as topological sort order. So we can get rid of this and this also. So here you can see we are done with our coding, and at the very last what we have to do, we have to simply return this thing. That is, if the value of the count is equal to the total number of courses or not. This, if it is returned true, means we have successfully visited all the nodes or all the courses of the graph. And if it returns false, means there exists a cycle in the graph. And that's it. This is the end of our coding. And you can see it is very easy. What we did, we just did a simple thing, and that is the creation of the graph object. That was the only prerequisite to solve this problem. Apart from that, it is the same old Kahn's algorithm that we did in our last video. So let's click on run and let's see everything is working fine or not. So here you can see I have created few typos over here because I was copying from the other code, and that's it. You can see we have successfully passed both our test case. And you can easily understand that there was nothing in this problem if you know the Kahn's algorithm. So let's click on submit and let's see whether we pass all the test cases or not. So let me click on submit, and great. Here you can see with the same code what we have learned in our last video, we have also solved a medium problem on graph so easily. See, I told you solving problem on graph is very easy if you just know few of the algorithms. Now let's proceed further with a small bit of enhancement and the follow-up question of this one, and that is the course schedule part 2. So let me open that question also. And here this is the question, that is the course schedule 2. This is basically a follow-up question for the part 1. So this was the part 1 and this is part 2. And the only change that is present on this part 2 is this line. That is, here, apart from returning true or false that we did in our first problem, here what you have to do, here you just have to return the valid ordering of the courses. Means you have to return the topological sort. That's it. And I hope you already know how to do that. So let's copy the same code and let's also solve this problem in few seconds. So what we'll do, we'll copy the same code from here and let's copy the same code also from here and let's modify it accordingly. So here what we did, we have copied everything, and here instead of returning true and false, we have to just return the topological sort. For that, what we'll do, we will simply create an array called as toposort, and here we have to simply populate the values. So what we'll do, simply here we will pass the toposort as an array and we will get the values over here. So I hope this is clear. Now what we have to do, we have to simply return this toposort array in our result only if it is possible to do a toposort. So if you just read the question carefully, here it is telling that if there are many solutions, return any one of them, that is fine. But if it is impossible to finish all the courses, means if there is a cycle in the graph, then return an empty array. So this is the only check that you have to do before returning the solution. So what we'll do, simply here we will put a condition, that is a ternary operation, that if it is possible to return, then we will return this toposort from here. Otherwise, we will simply return an empty array. And that's it. We are also done with this coding. Let's click on run. And great, here you can see we have successfully passed all the test cases over here. So let's also click on submit, and great, here you can see we have successfully solved both the question, that is the code schedule part 1 as well as part 2 with the simple Kahn's algorithm that we have learned in our last video. So hopefully you have thoroughly understood the problem and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on our next video where we will be solving another problem on graph and we will see how easy it is to solve any problem on graph. So see you on our next video. Thank you.